What's up guys, this is Massey. Welcome to another video. This video is the second part of Introduction to Matrix Calculation. If you haven't watched the first part, I highly recommend you to go back and start from the first part. In the second part, I start with solving this question. Solve the matrix equation x times a equals to b. A is 2 by 2 matrix and b is 2 by 2 matrix as well. So if I define x as something like A, B, C, D, we're gonna have A, B, C, D times 1, 2, 3, 1, 2, 2, 3 equals to 2, 1, 1, 3. Then you multiply it. The answer is gonna be A times 1, A plus 2 times B, 2B. A times 2, 2A plus 3B. C times 1, C plus 2D. C times 2, 2C plus 3D. That has to be equal to 2, 1, 1, 3. So we're going to say A plus 2B is 2. 2A plus 3B is 1. C plus 2D is 1. 2C plus 3D is 3. Now we need to solve it for A, B, C, and D. So 2A plus 3B is 1 and A plus 2B is 2. So what I'm gonna do, I'm gonna use substitution method. A will be 2 minus 2b, and I sub it in the second equation. 2 times 2 minus 2b plus 3b equals to 1. So 4 minus 4b plus 3b equals to 1. So negative b equals to 1 minus 4. So negative b is negative 3. So b will be 3. So when you sub it there, it's going to be A plus 2 times 3 equals to 2. 2 minus 6, which is going to be negative 4. So A is negative 4, B is 3. Now let's solve this one. Again, I'm going to use substitution method. C equals to 1 minus 2D. Sub it there, 2 times 1 minus 2D plus 3D equals to 3. 2 times 1, 2, minus 2 times 4D, 3D, 3, negative D. 2 move it over there, it's going to be negative. So D will be negative 1. When you sub it there, 1 minus 2 times negative 1 is going to be 1 plus 2. C is going to be 3. So now we have A, B, and C, and D. So the matrix of X is going to be negative 4, 3, 3, and negative 1. That's going to be the matrix. Next topic is transpose. For any matrix A, the transpose of A is defined to be the matrix obtained by interchanging the rows and columns in A. The response of A is denoted by AT or A prime. If A is an m by n matrix, then the transpose AT is an n by m matrix given by, for example, here we have this matrix 1, 2, negative 1, 3, negative 1, 2. It says write the transpose of this matrix below. So I'm going to say AT is going to be, this one is 2 by 3, so AT is going to be 3 by 2. Going to be 1, 3, 2, negative 1, and 2. So that's just going to be the transpose of this matrix. Next example. What is the transpose of A? 4 by 4 matrix. It means that the transpose is going to be 4 by 4 as well. So that's going to be 2, negative 4, 1, 2, 3, Oh, actually this one is 4 by 3, so it's going to be 3 by 4. So that's when -3, -2, 6, and -3. And here we have 4, 3, 5, and -1. So this one is 4 by 3. So this one is going to be 3 by 4. That's the transpose of this matrix. Now in this example, it says consider the following matrices A and B. Both of them are 2 by 3 matrices. And it says compute transpose of A, transpose of B, transpose of A plus transpose of B, A plus B, A plus BT. So I'm gonna say AT. A is 2 by 3, so AT is gonna be 3 by 2. So it's gonna be 2, 3, 1, -4, -1, 5. BT, I'm gonna write it here. It's gonna be 3 by 2 as well. -1, 2, -3, -2, 1, and 4. Then AT plus BT, you need to add them. Since they have the same dimension, we can add them. This one is 3 by 2, 3 by 2, so we can add them. 2 plus -1, 1. -4 plus -2, -6. 3 plus 2 is going to be 5. -1 plus 1 is going to be 0. 1 plus -3 is going to be -2. 5 plus 4 is going to be 9. So that's AT plus BT. Now next one, it says find A plus B. A plus B. This one is 2 by 3, 2 by 3, so A plus B is going to be 2 by 3 as well. 2 plus -1, 1. 3 plus 2 is going to be 5. 1 plus -3 is going to be -2. -4 and -2 is going to be -6. -1 and 1 is going to be 0. 5 and 4 is going to be 9. So that's the A plus B. Now the last part, it says A plus B to transpose of A plus B. So AB transpose is going to be transpose of this. This one is already 2 by 3. It means that the transpose is going to be 3 by 2. So 1, 5, -2, -6, 0, and 9. Now if you compare it with this one, you see you have exactly the same answer. So we're going to say A plus B transpose equals to AT plus BT. Next example, it says consider the following matrices. A is 2, -3, 1, -1, 4, -2. B is 4, -3, 1, 2, -1, -2. 3, -2, -1. Compute AT, BT, AT, BT, A times B, and AB, T. So AT is going to be the transpose of A. A is 2 by 3, so the transpose is going to be 3 by 2. So it's going to be 2, -1, -3, 4, 1, and -2. Transpose of B is going to be 4. That's 3 by 3, so the transpose is going to be the same dimension. 4, 2, 3, -3, -1, -2, 1, -2, -1. So that's the transpose of matrix B. And then it says find out AT times BT. So AT times BT. AT is 3 by 2. BT is 3 by 3. So basically we cannot find AT BT because it's 3 by 2, 3 by 3, so we cannot do that. We learned it in the first part of this course. But we can find BT AT because BT is 3 by 3 and this one is 3 by 2. So that's gonna be 4, 2, 3, -3, -1, -2, 1, -2, -1, multiplied by 2, -1, -3, 4, 1, -2. So the answer is supposed to be 3 by 2. because it's 3 by 3, 3 by 2, so the answer is going to be 3 by 2. So 4 times 2, 8, minus 6, plus 3, which is going to be 5. 4 times negative 1, negative 4. 2 by 4 is 8. 3 by negative 2, negative 6. So negative 4 plus 8 minus 6 is going to be negative 2. Next one, negative 3 by 2 plus negative 1 by negative 3 plus negative 2 by 1. So it's going to be negative 6 plus 3 minus 2, which is going to be negative 5. Negative 3 by negative 1, negative 1 by positive 4, negative 2 by negative 2. So it's going to be 3 minus 4 plus 4, which is going to be 3. Next one, 1 times 2 plus negative 2 times negative 3 plus negative 1 times 1. So it's going to be 2 plus 6 minus 1, which is going to be 7. 1 times negative 1, negative 1. Negative 2 by 4, negative 8. Negative 1 times negative 2 is going to be positive 2. So negative 1 minus 8 plus 2 is going to be negative 7. So that's BT times AT. Now it says, what is ABT? So let's multiply A by B first. A is 2, negative 1, negative 3, 4, 1, negative 2. B is 4, 2, 3, negative 3, negative 1, negative 2, 1, negative 2, negative 1. So that's 2 by 3, and here is 3 by 3. The answer is going to be 2 by 3. So when you multiply it, 2 by 4, negative 3 by 2, 1 by 3, that's 5. 2 by negative 3, negative 3 by negative 1, 1 times negative 2 is going to be negative 5. 2 by 1, negative 3 by negative 2, 1 by negative 1 is going to be 7. Negative 1 times 4, 4 by 2, negative 2 by 3 is going to be negative 2. Negative 1 by negative 3, 4 by negative 1, 2, negative 2 by negative 2 is going to be 3. Negative 1 times 1, 4 by negative 2, negative 2 by negative 1, it's going to be negative 7. So that's A by B. Now what is the transpose of AB? It's going to be a 3 by 2, 5, negative 2, negative 5, 3, 7, negative 7. And as you see here, that's exactly what you got in here. So transpose of A times B equals to the transpose of B times the transpose of A. So I'm going to write A, B, transpose equals to transpose of B times transpose of A. Now let's see what is a symmetric matrix. A symmetric matrix, or matrix A, is said to be symmetric if it is equal to its transpose. It means that A equals to AT. So if A, matrix A, with elements Aij, the A is called symmetric if Aij equals to Aj for all I and j. Note that if A is an M by N matrix, then transpose of A is an N by M matrix, and therefore A can be symmetric only if A is a square matrix. We learned square matrix in part 1. It says when the number of rows and number of columns are the same. Now in this example, let's figure out if matrix A is a symmetric matrix. So the first thing I'm going to do, I'm going to find out the transpose. As you see here, that's square matrix because it's 3 by 3. Number of rows and number of columns are the same. So it's going to be 1, 2, 0, 2, negative 1, 4, 0, 4, 3. That's exactly the same thing. So we're going to say, yes, it is a symmetric matrix. Now next concept is skew symmetry. A square matrix A, which elements are defined as Aij, is said to be skew symmetric if Aij equals to negative Abi. So it is very similar to the symmetric, but the signs are different. So for all A and J, in other words, A is skew symmetric if and only if A equals to negative At, negative transpose of A. Let's see if this matrix is a skew symmetric. It is 4 by 4, so that's square, which is the good thing. Let's write down the transpose. 0, 2, 3, 4, negative 2, 0, 1, negative 3, negative 3, negative 1, 0, negative 1, negative 4, 3, 1, and 0. Now if you compare these two, 0 is 0, 2 becomes negative 2, 3 becomes negative 3, 4 becomes negative 4, negative 2, 2, 0, 0, 1, negative 1, negative 3, 3, negative 3, 3, negative 1, 1, and so on. So as you see here, that's the same but in opposite sign. So it means that that's the skew symmetric matrix. Now let's see the next example. It says verify if A is a skew symmetric matrix as well. I'm gonna call it, let's say, B. 1, 2, 3, 4, negative 2, 0, 1, 3, negative 3, negative 1, 0, and 2, negative 4, negative 3, negative 2, 0. So as you see here, that's the same thing. Negative 2 becomes 2, for example, 1 becomes negative 1, 3, negative 3, and negative 3 becomes positive 3. So yes, it's gonna be skew symmetric matrix. Let A be a square matrix, then A is symmetric if and only if the transpose of A is symmetric. Let A be a square matrix, then A is skew symmetric if and only if the transpose of A is skew symmetric. For any square matrix A plus transpose of A is symmetric and A minus transpose of A is skew symmetric. These are very important notes. Any square matrix can uniquely expressed as sum of a symmetric matrix and a skew symmetric matrix, like before. Let A be a symmetric matrix, then A to the power of n is also symmetric for all positive integers, like A to the power of 2, A to the power of 3, stuff like that. Then let A and B symmetric matrices of the same order, then AB is symmetric if and only if AB equals to BA. Now in this example, it says express the matrix A as a sum of symmetric matrix and a square skew symmetric matrix. So A is 3 by 3. So to do this, we need to calculate 1 over 2 A plus transpose of A, 1 over 2 A minus transpose of A. So transpose of A is 2, 3, 1, negative 1, negative 2, 4, 5, negative 3, negative 5. So 1 over 2 A plus AT is gonna be 1 over 2 of addition of these two, 2 plus 2, 4, 3 minus 1 is 2, 1 plus 5, 6, 3 by negative 2, negative 1 is going to be 2, negative 2 and negative 2, negative 4, negative 3 and 4 is going to be 1, 5 and 1, 6, 4 and negative 3, 1, negative 5 and negative 5, 10. Then if you find half of it, it's going to be 2, 1, 3, 1, negative 2 half, 3 half, negative 5. Next one is 1 over 2, a minus at. So 2 minus 2, 0. 3 minus negative 1, 4. 1 minus 5 is negative 4. 1 minus 3 is negative 4. Negative 2 minus negative 2 is going to be negative 2 plus 2 is 0. 4 minus negative 3, 7. 5 minus 1, 4. Negative 3 minus 4, negative 7. Negative 5 minus is going to be 0. Half of it is going to be 0, 2, negative 2, negative 2, 0, 7 over 2, 2, negative 7 over 2, and 0. So you need to show it as addition of these two. So it's going to be 2, 1, 3, 1, negative 2, 1 over 2, 3, 1 over 2, negative 5, plus 0, 2, negative 2, negative 2, 0, 7 over 2, 2, negative 7 over 2, and 0. So that's going to be the sum of a matrix, symmetric matrix, and a skew symmetric matrix. That's the symmetric matrix, and this one is the skew symmetric matrix. Next topic is orthogonal matrix. A square matrix A is said to be an orthogonal matrix if transpose of A times A becomes I, which is identity matrix of order same as the A. Verify if the matrix is orthogonal. A is 2 by 2 matrix, so we need to figure out if AT times A is I. So transpose of A in this case is going to be cosine theta, negative sine theta, negative sine theta, and cosine theta. So when you multiply that, cosine theta, negative sine theta, negative sine theta, cosine theta, times cosine theta, negative sine theta, negative sine theta, cosine theta. When you multiply that, cosine times cosine plus negative sine times negative sine is going to be cosine squared plus sine squared, which is going to be 1. Cosine theta times negative sine theta plus negative sine theta times cosine theta, which is going to be sine theta cosine theta minus sine theta cosine theta. That's going to be 0. Then negative sine theta times cosine theta plus cosine theta times negative sine theta. That's going to be cosine theta sine theta minus sine theta cosine theta. So it is going to be 0. And at the end, negative sine theta times negative sine theta plus cosine theta times cosine theta is going to be 1, because sine squared plus cosine squared is always 1. So here we have identity matrix. So we can say A is an orthogonal matrix. Now next example, verify this one if it's orthogonal. So again we do the transpose, sine, cosine, negative cosine, sine. Then you multiply them, sine theta, negative cosine theta, cosine theta, sine theta. Multiply by sine theta, cosine theta, negative cosine theta, sine theta. So first of all, sine theta times sine theta plus negative cosine theta times negative cosine theta, that's going to be 1. Sine theta times cosine theta minus cosine theta sine theta is going to be 0. Cosine theta times sine theta plus sine theta times negative cosine theta is going to be 0, because both of them are the same. Cosine theta plus sine theta times sine theta is going to be cosine squared plus sine squared is going to be 1. So that's the identity matrix. So we're gonna say A is an orthogonal matrix. So next example is saying that let A be this matrix, find the values of A, B, C such that A is an orthogonal matrix. So the first thing I'm going to do, I'm going to find out the transpose of this matrix, which will be 0, 2B, C, A, B, negative C, A, negative B, C. Then you multiply them. 80 times A is going to be this row times this column, this row times this column, this row, this column. It's going to be the first row. Then this times this, plus this times this, then this times this is going to be second row, and so on. So when you multiply that, 0 times 0 plus A times A plus A times A is going to be 2A squared. This times this part is going to be A, negative AC plus AC is going to be 0. Then we have this times, actually it was AB minus AB is going to be 0, same thing, and here is going to be 0 as well. Then the second row, 2B times 0 is 0. B times A plus negative B times A, that's going to be 0. Then 2B times 2B is going to be 4B squared. B times B, B squared. Negative B times negative B is going to be positive B squared. So it's going to be 6B squared. Then 2B times C plus negative B, B times negative C plus negative B times C, that's going to make it 0. Then C times A and C times 0, 0. Negative C times A and C times A is going to be 0. C times 2B plus negative C times B plus C times negative B, that's 0 as well. And at the end, C times C, C squared. Negative C times negative C, again C squared. C times C is going to be C squared, so it's going to be 3C squared. If A is orthogonal, this one has to be equal to an identity matrix. So it means that 2A squared has to be 1, 6B squared has to be 1, 3C squared is going to be 1 as well. So A is going to be plus minus 1 over root 2, B is going to be plus minus 1 over root 6, and C is supposed to be plus minus 1 over root 3. So that's going to be the values of A and B and C in order to have A as an orthogonal matrix. Now I want to talk about elementary transformations or elementary operations. Sometimes we can change the two rows or two columns, so it is called interchange of any two rows or two columns. For example, we have this matrix that's 3 by 4. We want to exchange or interchange second row with third row, which is shown by R2, row 2 and row 3. So when we switch these two, we can write it like that. So as you see here, third row and second row is switched, which is going to give you exactly the same matrix. Or you can interchange first column and third column, C1, C3. If you compare these two, C1 and C3, they switch and it's going to be 3, 1, 3, 1, 4, 1. Another one, the multiplication of any row or column by a non-zero scalar. For example, we have this matrix and we want to multiply the third row by 2. So R3 gives you 2R3. So the third row, 1 becomes 2, 4 becomes 8, negative 3, negative 6, 1 and 2. The rest is going to be the same. Or we multiply the third column by 2. So third column is negative 2, 4 and third column is negative 1, 2 and negative 6. When you multiply it by 2, you get the answer like this here. And then the addition of the elements of a row or a column and the corresponding elements of any other row or column multiplied by a non-zero. For example, we have this matrix and we apply the transformation of R2 to become R2 plus 3 times R1. So it's going to be R2, the new R2 is going to be R2 plus 3 times this. So the first element of the second row is going to be -1 plus 3 times 2. The second element is going to be 2 plus 3 times 3, -3 plus 3 times 1, 2 plus 3 times 4. The rest is going to remain the same, and then you evaluate it. So these are the transformations of elements in a matrix. Next concept is when we are dealing with a matrix which is invertible or non-singular. Square matrix A of order n is said to be invertible or non-singular if there exists a square matrix B of order n such that A times B equals to an identity matrix, which is also going to be equal to B times A. B is called inverse of A and is denoted by A to the power of -1. Now in this example, I want to see that if B is inverse of A. So if B is the inverse of A, we should say that A times B must be equal to I. In this case, I3, because we are dealing with 3 by 3 matrix. So if we multiply A by B and we get identity matrix, it means that B is inverse of A. So we have 2, -1, 3, -5, 3, 1, -3, 2, 3, multiply by -7, -9, +10, -12, -15, +17, 1, 1, -1. So when you multiply that, this by this, 2 times -7 is going to be -14. -1 times -12 is going to be +12. 3 by 3 is going to be 3 by 1 is going to be 3. Then 2 by -9 is going to be -19. -1 by -15 is going to be +15. -18 and +15, -3 so far, and with this 3 is going to be 0. 2 by 10, 20. -1 by 17, -17. And 3 by -1 is going to make the whole thing 0. -5 times -7, 35. 3 by -12 is going to be -36. 1 by 1 is going to be 1. So that's going to be 0. -5 by -9, 45. 3 by -15 is going to be -45. And 1 by 1 is going to be 1. -5 by 10, -50. 3 by 17 is 51. 1 by -1 is going to be -1. That's going to make it 0. -3 by -7, 21. 2 by -12 is going to be -24. 3 by 3 is going to be 3 by 1 is going to be 3. That's going to be 0. -3 by -9 is going to be 27. 2 by -15 is going to be -30. 3 by 1 is going to be 3. So that's going to make it 0 as well. -3 by 10, -30. 2 by 17, 34. 3 by -1 is going to be -3. So the whole thing is going to be 1. So as you see here, the answer is going to be 1, 0, 0, 0, 1, 0, 0, 0, 1, which is I3. So we're going to say B is an inverse of A. Two notes here. Let A and B be invertible square matrices of the same order. Then AB is invertible, and AB inverse of AB is B inverse of B times inverse of A. So that's how we can convert it. A square matrix A is invertible if and only if its transpose is invertible. So the inverse of transpose of A equals to the transpose of inverse of A. Now in this example, I want to find out the inverse of this matrix. It is 3 by 3 matrix, and we know when we want to find out the matrix, the inverse of a matrix, we need to write it like that, and then we have an identity matrix times A. Then what I need to do, I need to change this matrix to an identity matrix. First thing, we need to switch the second row with the first row. So it's going to be 1, 2, 3, 0, 1, 2, 3, 1, 1. And here we need to do the same thing, 0, 1, 0, 1, 0, 0, 0, 0, 1. Then what we need to do, we need to say R3 to change to R3 minus 3R1. So 1, 2, 3, 0, 1, 2 remains the same, but here is going to be 3 minus 3 times 1, 0. 1 minus 3 times 2, negative 5. 1 minus 3 times 3, negative 8. Here, 0, 1, 0, 1, 0, 0. Here, 0 minus is going to be 0. 0 minus negative 3. And here we have 1. Then what we can do, we can change the first row R1 to basically we want to basically get rid of this. So R1 to R1 minus 2R2. So second row and the third row remains the same. And the first row is going to be R1 minus 2R2. So it's 1 minus 2 times 0. 2 minus 2 times 1. 3 minus 2 by 2, which is going to be negative 1. Here, R1 minus 2R2. So it's going to be negative 2. Here we have 1, and here we have 0. Then what else we can do? We need to basically make this one 0. So what we can do, we can say R3 to change to R3 plus 5 times R2. So R3 change to R3 plus 5R2. So the first and second remains the same. R3 is 0 plus 5 times this is going to be negative 5 plus 5 times 1. Negative 8 plus 5 times 2, which is going to be positive 2. Same thing here. The R1 and R2 remains the same. R3 plus 5 times this one is going to be 5. Here, that's going to be negative 3 plus 5 times 0, which is remaining the same. And 1 plus 5 times this one is just going to be 1. So perfect. So we just need to get rid of these two. Let's get rid of basically this first. So we need to deal with R2. And also here we need to make this one 1 as well. So let's divide the third row by 2. So R3 to change to half of R3. So it's going to be 1, 0, negative 1, 0, 1, 2, 0, 0, 1, negative 2, 1, 0, 1, 0, 0, 5 over 2, negative 3 over 2, 1 over 2, A. Perfect. Now let's make these two zeros. So I want to make this 0. So I change R2 to R2 minus 2R3 or plus 2R1. Doesn't matter which one, but it's easier to do this one because we have only one of them. So the first row and the third row remains the same. R2 is going to be R2 minus 2R3. So that's going to be 0 minus 2R3, 0. This one remains 1. And this one is supposed to be 2 minus 2 times 1, which is going to be 0. Here, that's going to change to 1 minus 2 times 5 over 2, which is going to be 1 minus 5, which is going to be negative 4. Here, 0 minus 2 times negative 3 over 2, which is going to be negative times negative 3 is going to be positive 3. And here we have 0 minus 2 times R3, which is going to be negative 2 times 1 over 2, which is going to be negative 1. One more step in order to make this negative 1 0. So I'm going to change R1 to R1 minus R3. 0, 0, 1, 0, 1, 0. And here, 1 minus 0, 1, 0 minus 0, 0, negative 1 minus, it's going to be 0. Basically, R plus R3. So, this one is going to be negative 2 plus 5 over 2 is going to be 1 over 2. 1 plus negative 3 over 2 is going to be negative 1 over 2. 0 plus 1 over 2 is going to be 1 over 2. The rest remains the same. So since this one is identity now, this matrix is the inverse matrix, or that's A to the power of negative 1. That's the inverse of A. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.